Shall I start? So, good evening, everyone. Welcome to YouTube session 4. That is, today I am going to discuss, that is, a lecture on probability and statistics. In the previous classes, we had discussed matrices, numerical methods. Now, today, probability statistics. Before going to discuss, we have to learn or discuss some basic definitions. The next slide. This is permutation and combination, which is from 11th class. Many of the probability problems relate to combinations. Few problems relate to permutations, that is the dice problems, etc. You will understand slowly. Now, permutation definition. An arrangement of some or all of the given objects. Objects or things. You have three objects, say A, B, C. All of the objects can be arranged in a line, or two objects, one object, that is sum of the given objects, arranged in a line. Such arrangement is called a permutation. How many arrangements, that is how many permutations, that I will explain later. So if the objects are arranged in a line, then it is called linear permutation. Otherwise, it is called circular permutation. If the objects arranged in a circular permutations, you will get in aptitude. Okay. Now, the number of linear permutations of n distinct objects. Distinct objects means, let us take the three objects, pencil, eraser, pen, like that. Taken R at a time. That means out of three objects, if I take two objects, if I take one object, that is called R objects taken at a time, is denoted by NPR. Okay, the prefix N, the suffix R, N is the total objects, R is the, we are arranging sum of the objects, P stands for permutation notation. Some people denoted by P of N comma R and is given by NPR is equal to N factorial divided by N minus R factorial, where R less than or equal to N. That means from the given objects, either you arrange all the objects or sum of the objects. That means less than or equal to. From three objects, I can't arrange four objects. So that's why R value less than or equal to N. This definition is without repetition of objects. What is without repetition of objects means? So I can take from the three objects, pencil, pen, eraser, pencil, comma, pen, pen, comma, eraser. That is called repetition without. Okay. See, to understand in a better way, I am taking three objects. Let N is equal to three objects, say A, comma, B, comma, C. Let us denote our childhood class notation: A for apple, B for ball, C for chocolate. Then R is equal to two objects. So I am taking R value 2. Two objects can be arranged in apple, comma, ball or banana, whatever it may be, B, comma, A. Arrangement means order of the arrangements is considered. That is, order is important. A, comma, B, B, comma, A, both are different. B, comma, C, C, comma, B, C, comma, A, comma, C. Total ways, this is 6 ways. Okay. These 6 ways, according to the formula, how much I gave? NPR. N stands for 3, R stands for 2, 3P2. This 3P2 answer according to my first box, rectangular box, 3 factorial divided by 3 minus 2 factorial. 3 factorial means 3 into 2 into 1. 2 factorial means 2 into 1. Okay. That is, this is 6 ways. So, why I am explaining in this way? If I take 10 objects, that is total objects is 10. I want to arrange 5 objects. So 10p 5 ways. I can't write all of these objects. If you take all of these ways if I take more number of objects. So this is for just understanding this NPR notation only. Okay. Now, the next one is, suppose if I take all the given n objects can be arranged in how many ways? N factorial ways. Okay. That is the number of linear permutations of n distinct objects taken all at a time that I am writing here. The number of linear means we are arranging in a line permutations of n distinct objects taken all at a time. That is, your R value is equal to n. Is nothing but npn, which is n factorial ways. Okay. Now coming to combination. Combination related to the meaning selection. Permutation related to arrangement. In combination or selection, order of the object is not important. That is, a comma b is same as b comma a. So a selection of some or all of the given objects is called a combination. Now there are 3 to 5 objects or 10 objects. I want to select 5 objects. I can't write each and every way like this. If I take 3 objects, 4 objects, and I can select 2 objects, I can write one by one way. If I take more objects, so there is a formula based invented by the scientist. The number of combinations of, again, n distinct objects. You are given all objects should be distinct, no repetition. Taken R at a time is denoted by NCR or C of n comma R, and is given by NCR is equal to n factorial divided by n minus R factorial into R factorial, same as above, R less than or equal to n. Okay. So this NCR is also denoted by, is also given by NPR divided by R factorial. Now, NCR is equal to NCn minus R. I will explain how to do. For this, you have to remember NC0 without writing factorials procedure. I am explaining some standard results. NC0 value 1, NC1 value n, NC2 value n into n minus 1 into 2 into 1. So NC3 value n into n minus 1 into n minus 2 divided by 3 into 2 into 1, and so on. If I select all the given n objects in one way only. So what does it mean? NCR is equal to n minus R. When n and R very close to each other, then this formula helps. So let us say 9C8. 9C8, how do you evaluate? Just like this, 9 into 8 into 7 into, it takes little bit more time. 9 and 8 are very close. The difference between 9 and 8 is very small. So I can use 9C 9 minus 8, which is nothing but 9C1, which is nothing but 9. So you can use that NC0, NC1 procedure. After cancellation, you will be getting again 9, but we can save that time. Okay. So I am moving to the probability definitions. After that, problems. So random experiment. Before that, what is outcome? What is trial? Trial, T-R-I-A-L. A performance of an experiment. For example, what is performance means? Take a coin game. How do you perform? Like this. That means a coin tossed. If I take a coin, this is the performance, tossing a coin. Okay, that is called trial. Throwing a die, this is called performance. Okay. Now, once you perform, that is after the trial, you will get a result. That is, the result of a trial is called outcome. Okay. Outcome means whatever it may be, true, false. If a coin is tossed, your outcome is either head or tail. That is the meaning of outcome. Now experiment. This is, you know, everyone. An experiment with unpredictable outcomes is known as random experiment. For example, when you are tossing a coin, before tossing, if you say the answer head and the answer is, Every time, whatever you are saying after tossing a coin, before tossing a coin, both are same. That is not fair game. That is unpredictable outcomes means we know the outcomes, that is head or tail, but we can't give the sure 100% compulsory head, compulsory tail. That is called the meaning of unpredictable outcomes. So it can be conducted any number of times under essential identical conditions. What is identical conditions? So again, I'm showing that coin game tossing like this. Same conditions, falling on the ground or falling on our arm or hand. In the next time, if you toss a coin, not like this, not like this. That is, keep under the same identical conditions, whatever you are playing the game. Okay. Now, sample space definition. You know the meaning of outcome, the result of a trial. Okay. Set of all possible outcomes of an experiment is called the sample space, denoted by S. That means whatever you are playing, any experiment, random experiment, total outcomes, all possible outcomes, if you are considering a set, such a set is called sample space. Now I am explaining a few standard examples. Okay. Coin game, dice game, etc. Example. Number 1, tossing a coin once, that is one time. Yes, sample space is equal to H stands for head, T stands for tail. Head and this is tail. So total outcomes, that is mod S. Some people in our childhood classes, we have denoted by N of S. Computer science people, information technology, IT people, they are denoted by mod S is equal to 2 power 1, 2 outcomes. Total outcomes, this is 2. The same game, tossing a coin twice, 2 times, or 2 coins tossed once. 2 coins tossed once, both are having same meaning. S is equal to HH. What is the meaning of HH? First coin gives head, second coin shows head. HT, TH, TT. So total outcomes, mod S is equal to 2 square. So on. If I play n times, that is tossing a coin n times, your mod S is 2 to the power n. If I toss 10 times, writing all the outcomes takes minimum 1 hour. So better standard result is 2 power n, where n is the number of times a coin is tossed or n coins tossed once. Now the second standard example, throwing a dice once. So cubical dice, this is fair dice, fair coins only. So all the outcomes having same chance. That is the meaning fair or unbiased coin. Okay. So 6 faces in a cubical dice, each face having 1 dot or 2 dots or 3 dots or 4 dots or 5 dots or 6 dots. So the number of dots is 1, 2, 3, 4, 5, 6. So what is the meaning of this 1 to 6? Number of dots on a face. Okay. So implies mod S is equal to 6 power 1, 6. The same game, throwing a dice, fair dice or unbiased dice, fair coin or unbiased coin, both are same, twice, or 2 fair dice thrown once. Both are having same meaning. S is equal to 1, 1. That is first die 1 dot. Second die is also 1 dot. 1 comma 2. First die gives 1. Second die gives 2. Like that 1, 3, 1, 4, 1, 5, and maximum up to 1 to 6. Similarly, 2, 1. First dice gives 2, second die gives 1. 2, 2, 2, 3, and 2, 4, 2, 5, 2, 6. So like that, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Next, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Last row, 6, 1, comma, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So total outcomes, mod S is equal to number of elements in a set S, that is sample space, 6 square 36. If I throw a fair dice 10 times, the total outcome 6 power 10. Like that, n times throwing a dice, the total outcomes is 6 power n. Okay. Now, this is the definition of event. Any subset of sample space is called an event. Subset means you have some set A. One element or two elements. Any part of a given set is called subset. Smaller set is called subset. So, usually events denoted by capital A, capital B, capital E, etc. For example, let E is equal to sum of the upturned numbers is 7. So, please underline sum upturned numbers is 7 means in which experiment, random experiment is throwing a dice twice. A dice is thrown twice. Just now I explained in this mod S is equal to 36 outcomes. So on the two dice, dice thrown twice or two dice thrown once, both are having same meaning. The top faces, upturned numbers means number on the top face. Just add. That value is 7. For that 7, what are the favorable outcomes? 1, 6. 1 plus 6, 7. First die gives 1. Second time gives 6. 2 plus 5, 7. 3 plus 4, 7. 4 plus 3, 7. 5 plus 2, 7. 6 plus 1, 7. So total favorable outcomes. The number of favorable outcomes belongs to the event. So that means number of favorable outcomes is related to an event. Favorable outcomes is mod E, which is nothing but 6. Okay. Now, definition of probability. The probability of an event E is denoted by P of A. Some people P of A or P suffix R. P suffix R denotes the symbol for probability of the event E or simply P suffix E. Any one of notation can be used and defined as the ratio between the number of outcomes favorable to the event and the total number of outcomes. You know the meaning of ratio? Ratio means division quantity. So division means numerator and denominator. Numerator means number of favorable outcomes, that is mod E. Denominator is total outcomes. So this is also denoted by mod E by mod S. Cardinality of a set is denoted by N of E or mod E. A is a set. What is the cardinality of a set? Total number of elements in that set, denoted by modulus symbol or n symbol. So where m is the favorable number of outcomes and n is the total number of outcomes. So probability is always lies between 0 to 1. Okay, you understood or not? For example, in the above event, the total favorable outcomes is 6 and mod S total outcomes is 36. So what is the probability of the event sum is 7 in the above example? 6 by 36, that is 1 by 6. Which is greater than 0, less than 1. Sometimes probability 0, probability 1. Now, N of E means number of elements in E. When probability of event E is equal to 0, such an event is called impossible event. Just general English language. Daily, we are looking at daily things. The probability that the sun rises in the east. Okay, sun rises in the east. If I consider the event E, what is the probability? That is 100% 1. The same question. The probability that the sun rises in the west. This is impossible event. That's why probability of the sun rises in the west is 0. So when the probability of event is equal to 1, such an event is called certain event or sure event. Okay. Now, A dash or A complement or A bar called complement of event A is the event which is not happening A. For example, I told you let event A is equal to that the sum is 7. What is A dash? That the sum is not 7. That is the meaning. So when they ask probability of not happening the event, that is P of A dash, don't find all the favorable, etc., etc. Just use this formula. P of A dash is equal to 1 minus P of A. That is, usually A dash is called, many people consider A dash is failure event, A is success event. So probability of success plus probability of failure is always 1. Okay. So that's why we are not given much importance on probability 0 and 1. No importance given to the problems generally, probability 0 and 1. Strictly lies between 0 to 1. Very few problems having probability answer 0 and 1. Okay. Now the next slide. So after few definitions, we'll start problems. Two events A and B are called mutually exclusive if they are disjoint. According to set theory language, A intersection B is equal to 5. What is 5? Empty set or null set or void set. What is this intersection? Taking all common elements. So common elements should be considered one time. That is called intersection. So in word language, that is verbal language, that is A and B cannot occur simultaneously. For example, throwing a dice once, that is your random experiment. Let event A, event A is equal to getting an odd number. So in dice game once, what is odd numbers? 1, 3, 5. Let event B is equal to getting an even number. What is even number on the dice? 2, 4, 6. A intersection B is equal to 5. When you throw a dice, is it possible at a time either odd number? That means at a time, is it possible odd number and even number? Either you will get odd number or even number. That is called mutual exclusive event. Similarly, two events A and B are said to be exhaustive if union of the two events is S. S stands for sample space. This S is sample space. In verbal language, A and B together includes all outcomes of S. That means the total sample space is distributed into two sets A and B, either equally distributed or partially distribution. Okay, that is. In the above example, I told you getting an odd number 1, 3, 5. Event B is equal to getting an even number 2, 4, 6. If you apply A union B, you will be getting 1, 2, 3, 4, 5, 6, which is the sample space S for the game or random experiment throwing a dice once. Now, addition theorem of probability. If A and B are any two events, then probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So why we are subtracting A intersection B? Let us see our 10th class Venn diagram. Usually Venn diagram sets are denoted by circles. So this is the rectangle, usually mu universal set. So this is S and this circle elements is A, this circle elements is B. So A is containing A intersection B, B is containing A intersection B. So union means writing all the elements in A and B one time. So that means here A intersection B is contained in both A and B. That's why we are subtracting one time A intersection B. So the shaded part, this is A intersection B. So which is involving in both A and B. Okay. Now, similarly, P of A union B union C. So first take single sets, add the probabilities. After the completion of single events, take the double events. There are three double events, AB, BC, AC. When you are changing the nature From single to double, change the symbol. So all the singles are pre-multiplied by plus, all the double events probability pre-multiplied by minus. After the completion of double events probability, then go to triple events. That is P of, here small typing error. Kindly excuse me. This is P of A intersection B intersection C and so on. Okay. So why I'm explaining addition, subtraction, plus, single to double, double to triple. If they ask P of A union, B union, C union, D, don't by heart these formulas. First all plus, then all minus, then all plus, etc. Now axioms of probability. That is 1 mark statement questions. Properties. Axioms means properties. Probability of empty set 0. What is this phi? Impossible event. Probability of S is equal to 1. That is probability of all total outcomes is always 1. Okay. For example, tossing a coin. Your outcomes is head and tail. Probability of getting head is 1 by 2. Probability of getting tail is also 1 by 2. 1 by 2 plus 1 by 2, 1. So S is always certain event. Phi is always impossible event. Now, probability of E1 union, E2 union, so on, En. That is union of n events is equal to sum of the probabilities. There is no common part. That is, when all the events are mutually exclusive, probability of union of the events is equal to sum of their probabilities. Just take care. This point, third point, is different from the addition theorem of probability. In the above addition of theorem probability, A and B are any two events, but here mutually exclusive events. Take care. So please underline mutually exclusive events. If A is a subset of B, that is every element of A is also in B, that is called subset. Don't say this is less than or equal to. Then probability of A less than or equal to probability of B. And here I am writing probability of A minus B. What is A minus B? Elements belongs to A but not in B. This is probability of A minus probability of A intersection B. Just this is, I will show by the diagram. The green color shaded part. See. This is called A minus B. In verbal language, this is only A. Some people, instead of only A, they are reading A but not B. Okay. So, and this part, the purple color, this is violet. This part is B minus A. Some people, verbal language, only B. Only B is also called B, but not A. The total two sets Venn diagram is divided into three parts. Only A, only B, common part A intersection B. Adding all these three, shaded all these three, that is called A union B. So outside these two circles, that is called neither A nor B. That is A dash intersection B dash. Okay. So here I am writing neither A nor B. In English language, both not exist, both fails. That is A dash intersection B dash. Okay. So, and you remember, sometimes these laws are useful, De Morgan laws. A intersection B whole dash is nothing but A dash union B dash. And A union B whole dash is equal to A dash intersection B dash. So similarly, distributive laws. A intersection B union C, same type of union, same type of intersection, that is associative laws. One intersection, one union, that is called distributive laws. Just like matrices chapter, A intersection B union C is equal to A intersection B union A intersection C. This is one example of distributive law. Similarly, another distributive law. A union B intersection C is equal to A union B intersection A union C. Okay, now we'll start a few examples. After that, conditional probability. See, the question number 1, get question. A single pair die. Some people dies or die. Okay. This is either die or you can write die. Single pair dice is thrown twice. So total outcomes 36. What is the probability that the sum is neither 8 nor 9? Just now explain neither A nor B. So solution. Here total outcomes, that is cardinality of the sample space mod S is equal to 36, which is nothing but 6 square, dice thrown twice. So let event A be denote getting sum 8. So sum 8 favorable cases 2, 6, 2 plus 6, 8 on the 2 dice. 3, 5, 4, 4, 2 dice or dice thrown twice. Both are having same meaning. 5, 3, 6, 2. Now let B denote getting sum 9. This sums 9 related to how many favorable outcomes? That is 3, 6, 3 plus 6, 9. 4, 5, 4 plus 5, 9. 5, 4, 5 plus 4, 9. 6, 3. So, from this, A intersection B, no common element. So, that is, this is the first example, that is standard example of mutually exclusive events. Mutually exclusive events. A and B are both mutually exclusive events. Now, therefore, required probability. What is required probability? The probability that the sum is neither 8 nor 9. So required probability, PROB means probability, is P of A dash intersection B dash. So what I told, A dash intersection B dash, P of A union B whole dash. This is called De Morgan laws. So what is P of A dash? 1 minus P of A union B. So here I am writing since probability of A dash is nothing but 1 minus probability of A. So what is addition theorem of probability? Either use addition theorem of probability or by the condition of mutual exclusive events. When two events are mutually exclusive, probability of union of the events is equal to sum of their probabilities. So 1 minus, what is probability of event A, sum 8, total outcomes in mod A, that is 5. Total outcomes in the event B, that is mod B, is equal to 4. So probability of the event A is mod A by mod S, that is 5 by 36. Probability of event B is mod B by mod S, that is 4 by 36. So this simplifies to 3 by 4. Now the next one. This is also GATE question. Solution. I am reading the question, explaining that a fair coin is tossed 10 times. Writing all the 2 power 10 outcomes is very difficult. It is time consuming. That's why I gave the formula in the first example of sample space 2 power n. What is the probability that only the first 2 tosses, please underline, only, very, very important, this only, the first 2 tosses, they are related to heads. Okay, 4 options ABCD given. So here mod S is equal to total outcomes 2 power n. Let A be an event denote. If you understand well, not required to write these words, verbal language. Okay, you can Go for direct answer also. They don't want that explanation. They want ABCD option, one of these or numeric question. But many people do not understand if I write direct answer. Okay. Let A be an event, denote that only the first two tosses will yield heads or heads. So this means you will be having only one favorable outcomes. Head, head. First coin, second coin gives head. Remaining only means remaining 8 tosses. Automatically tails. T, 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 T. So only very, very important problem. Don't confuse. Mod A is equal to 1. So this is highlight. This is the meaning. Only 2 tosses are heads. Which 2 tosses? That is also mentioned first. If they ask only 2 tosses means it may be second, third, second, 10th, like that. It is very difficult, that type of problems. Okay. So therefore, required probability is P of A is equal to mod A divided by mod S. Mod means cardinality of a set. That is number of elements in that set is equal to 1 by 2 to the power 10. 1 upon 2 raised to 10. Okay. The next. So conditional probability. Conditional events means it is also another meaning of dependent events. What exactly condition? Before explaining this concept, simple dice problem I am explaining. A fair dice thrown once. If the outcome is prime number, then what is the probability that it is an odd number? So already given that outcome is a prime number. What is the prime number from 1 to 6? 2, 3, 5. This is your modified sample space. So when an event is already happened, that is called given or if. Okay. So that is nothing but your original sample space. Yes, mod S is equal to 6 is now reduced. That is called modified sample space. Now your modified sample space is 2, 3, 5. That is 3 outcomes. Total outcomes 3. Based on that probability that it is an odd number. So in 2, 3, 5 total outcomes, how many favorable outcomes? Odd number 3, 5. So your favorable outcomes 2 and total outcomes is 3. 2 by 3 is the required probability. If I play 10 times or large number of times, writing the modified revised sample space and collecting the total favorable outcomes is time consuming, takes more time. So that's why the scientists, they have given the analytical or direct method or formula based procedure for finding these conditional or dependent events. See, let A and B be 2 events of a sample space S. The probability of B, that means we are finding the probability for event B after the occurrence of event A. So please underline after, very, very important. After the occurrence of event A. That means in A and B, in this sentence, A has happened first. We are finding the probability for B. So B is happening next. So B depends on A. Once an event already happened, the other events going to next happen. The other events are called depend on the previous events. So E is called the conditional probability of B given A. So if anyone asks, A given B means B happened first, A is going to happen next. C given D, D happened first, C is going to happen next. So this B given A probability is denoted by P of B by A or P of B. This is not slash, but of course slash symbol. Some people denoted by this division or slash symbol, P of B by A. And defined as P of B by A is equal to P of A intersection B divided by P of A. provided denominator not equal to 0. Probability denominator always not equal to 0. This is the condition. Similarly, the conditional probability of A given B, that means here B happened first, A is going to happen next, is denoted by P of A given B and is defined as P of A by B is equal to P of A intersection B divided by P of B if P of B not equal to 0. P of B not equal to 0. So B by A is read as B given A by B is read as A given B. In above definition, A and B are called conditional events or simply dependent events. Okay. So please by heart. So I will explain. This is a gate question. An unbalanced dice, that means all the outcomes are of different probabilities. With 6 faces numbered 1 to 6 is thrown. One time only thrown. Don't think that here probability of 1 dot is equal to probability of 2 dots is equal to all are same, because unbalanced dice. The probability that the face value is odd is 90% of the face value probability is even. Please underline. So the probability of getting any even numbered face is same. So let us start the solution steps for up to this one. So given probability of face value is odd, O stands for odd face value, is nothing but 90% of probability of E. E stands for even face value. Okay. So this implies 0.9 P of E. So let us take P of E is equal to X, which implies P of O is equal to 3 times X. Odd face and even face taken together, that is P of odd plus P of A. Sum of all outcomes in throwing a dice once, that is 1. So which implies 4x is equal to 1. X is equal to 0.25 or 1 by 4. That is the meaning. Now, P of E, even face, is same. The meaning? Even face means 2 or 4 or 6. Probability of 2 and 4 is not happened at a time. 4 and 6 not happened at a time. So 2, 4, 6 mutual exclusive event. So this implies P of 2 plus P of 4 plus P of 6 is equal to 1. So this means 3x. Okay. Is same. It's not 3x. Just a minute. So which means P of 2 is equal to P of 4 first, P of 6 is equal to, all are equal to X. Okay. So what is this? Probability of odd number plus even number. Kindly excuse me, this is 6x. P of O is 90% 0.9 and P of E is equal to X. So P of O is equal to, it's not 3x. This is 0.9x So this is 0.9x. This is 0.9x plus 1. 1.9x implies x is equal to 1 upon 1.9. Okay. So probability of 2 is equal to probability of 4 is equal to probability of 6 is x. Okay. That is each x is equal to 3. Now, so given that probability of any even number face is same, probability that the face is even, that is greater than 3, is 0.7. Okay. Probability of 2 plus probability of 4 plus probability of 6 is equal to 3x. That means 3 by 1.9. Now, what is this given? Take care. If the probability that the face is even, given that it is greater than 3 is 0.75. So, given probability of, which is happened here, face is even, given that, so that given sentence, after that given whatever the event greater than 3. So, even face divided by, that is given that face value greater than 3. So this is given 0.75. Now it looks like, let us denote A by B. So what is P of A by B? P of A intersection B, that is even face intersection face value greater than 3 divided by probability of face greater than 3 is equal to 0.75 using conditional probability. CP stands for conditional probability. So what is even face? 2 or 4 or 6. What is face greater than 3? 4 or 5 or 6. What is the common part? Probability of 4 or probability of 6. Usually or means adding, and means multiplying, general probability. Divided by probability of face greater than 3 is equal to 0.75. So the numerator is x plus x, 2x. Divided by 0.75 is equal to probability of face greater than 3. So face greater than 3 is also can be expressed as face value exceeds 3. Exceeding means greater than. Face value exceeds 3 is equal to 2 times of x. That is 2 into 3, 6 divided by 1.9 into 0.75. This is approximately 0.468. Accordingly, answer is option B. So I am taking P of E is equal to x. So probability of odd face is 90%, means 90 by 100 means 0.9, 0.9x. Probability of odd face plus probability of even. That is probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 is equal to 1. So that is 0.9x plus 1x is nothing but 1.9x is equal to 1. That x value is 1 by 1.9. Even face is same. That is probability of 2 is equal to probability of 4 is equal to probability of 6 is equal to x. So this step is not required actually. Okay. Now, given probability of even face, given that face value is greater than 3. So whatever given an event that is happened first, that should be put in the denominator. Now we are asking probability face is even. Face is goes to numerator according to comparing by P of A by B, conditional probability, that is. Okay. So now there is a multiplication theorem. multiplication theorem. What exactly multiplication theorem? When the question related to probability that the event will both happen, that means probability that both events happen, that is A intersection B. So A intersection B is also called both events A and B happen, verbal language. For any two events, A and B, comma, P of A intersection B is equal to P of A into P of B given A, or P of B into P of A given B. Just this is obtained from the above two boxes conditional probability. That means if first event A happened, which is multiplied by probability of event B, or if the first event is B happened, then it should be multiplied by probability of second event A after the B event. Okay. So please go through this. Please remember this. I'm explaining an example. Yes, this is a GATE question. Solution. An examination consists of two papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3 and that in paper 2 is 0.2. So first start with let A denote student failing paper 1. B denote student failing paper 2. From this information already given, P of A is equal to 0.3 and P of B is equal to 0.2. Now this is very important. Given that is already whenever in generally probability problems, understanding the question easily, but which topic comparing, that is very tough task. Given that is it is related to conditional probability. Student has failed in paper 2. That means he first failed in paper 2. The probability of failing in paper 1, English language, verbal language is important. So, and from the second sentence information, P of, he already failed in paper 2. Paper 2 is event B, paper 1 is event A. So, probability of the student failing in paper 1, given that he already failed in paper 2, that is the meaning. Which is answer 0.6. Now the question, probability a student failing in both the papers. Both means A and B. That is A intersection B. So therefore, required probability, PROB means probability, is P of A intersection B. So here which one happened? Student failed in paper 2. Paper 2 means B. So P of B multiplied with probability of the question related to failing in paper 1. Paper 1 means A, given that B. So here finally we are finding probability of event A after the occurrence of event B. So this is 0.2 into 0.6 is equal to 0.12. This is the answer. Now the practice questions. The question number 1, two persons A and B tossed an unbiased coin alternatively, such that first who gets the head wins. This is the event, head wins. But who is first tossed? That is here. A starts the game. That means first A tossing, then B tossed second time, third toss A, fourth toss B. That is called alternatively. Okay, take care. The probability of winning A, that is A's winning. Okay, see here. Let small p is equal to probability of getting head. In a coin toss at one time, probability of getting head is 1 by 2. Implies Q is denoted by probability of not getting head, that is tail, which is also 1 by 2. Okay. Since A starts game implies A gets H, that means head, in first throw or third throw or fifth throw, that is odd throws only. Or etc. That is odd throws. So that means P of A is equal to probability of getting head in the first throw, or means adding head getting in third throw means first throw gives tail, second throw gives tail, third throw gives head. This is the meaning. So take care. So what is first throw means? Coin tossed one time getting event head. If the coin tossed 3 times, that is third throw means 3 times. The first 2 throws getting automatically tails. What is TT means? First time throw gives tail, second throw gives tail, third throw giving head. That is head. Because our favorable outcome relate to head. R means adding. What is fifth throw getting head means? First time getting head in fifth throw means, first time getting head in fifth throw means all the first 4 throws tails. So that means P of T, 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 H. So take care. This is head and this is head and this is head. Our outcome related to winning the game, getting head first time. Understood or not? The previous throws failure, that is getting tail. So what is the answer? Getting head in first throw, that means coin toss at one time, 1 by 2. 3 throws, third throw means coin toss 3 times, total outcomes 1. 1 favorable outcome, TTH, 1 by 8. 5 times, that is 2 power 5, 32, 1 favorable outcome. So this 8 is 2 cube. This 32 is 2 power 5, 5 throws. In all these, 1 by 2 is common. Or this is nothing but PQ like that. Okay. So this is small p and this is Q small p and this is Q. Failure case means tail, small p. P means success case, getting head. So 1 by 2 is common. After that 1 plus 1 by 2 whole cube becomes whole square, plus 1 by 2 raised to 5 becomes 1 by 2 raised to 4, plus so on. So this looks like 1 by 2 into 1 minus 1 by 2 whole square whole to the power minus 1. Just from Taylor's or Maclaurin series or binomial expansions, 1 minus x whole power minus 1 is 1 plus x square plus so on. Now this is in place of x, we have 1 by 2 whole square. So this simplifies to 1 by 2. 1 minus 1 by 4 is 3 by 4. 3 by 4 reciprocal is 4 by 3. So this simplifies to 2 by 3. Accordingly, answer is option D. So, in this way, so please subscribe the channel. Okay. And GATEFORUM offering many courses, online, live, GATE classes, test series, 3 types of tests. chapter wise test, target test, topic wise test. Target test means based on the gate format. Next, uh, refresher course also many problems. They will provide 2010 to 2020 almost questions, explanations. So the next question, I'm doing this three. First of all, the probability that a number selected at random between 100 and 499 both inclusive. So total favorable, total outcomes is 400 numbers. If it is both exclusive, 398. So let us start third solution here only. Solution mod S total outcomes, that is 400, which is nothing but 4 into 10 into 10, 3-digit number. First to place, that is 100 to 499 means 100, 101, etc. 199, 201, 202, etc. 299, 300, 301, like that. The first 100th place, that is which is 1, 2, 3, 4 digits. The second place, 10th place is 0, 1, 2, 9, that is 10 ways. The third units place is also 0 to 9, that is 10 ways. Okay. Now, what is the event here? Will not contain digit 3. Let A, this is event, denote that selected number, 3-digit number, will not contain 3. Okay. So, implies mod A. Usually, again, first place, that is 100th place. 1, 2, 3, 4. Now 3 is ignoring, will not containing 3. So 3 ways into the 10th place, which may be from 0 to 9. Am I correct or not? But will not containing the digit means 0, 1, 2, 4, 5, 6, 7, 8, 9. So 9 ways. Ones place, units place, that is also will not containing the digit 3 means from 0 to 9, 10 ways. Ignore 1 way. So this is 9 ways. Okay. So required probability P of A is equal to 3 into 9 into 9 divided by 4 into 10 into 4. That is, sorry, 10. So this is 243 divided by 400. According to the options, you have to simplify further. Now, I'm going to discuss the second example. The probabilities of 3 events A, B, C are such that P of A is equal to 0.3, P of B is equal to 0.4, P of C is equal to 0.8. P of A intersection B 0.08, P of A intersection C 0.28, P of A intersection B intersection C 0.09, and P of A union B union C is greater than or equal to 0.75. Then they are asking the question P of B intersection C lies between. So that values given in the closed interval form. So take care this problem. Now I am doing third solution. Second solution. Okay, we know that P of A intersection B, P of B intersection C. This is P of A union B union C greater than or equal to 0.75. And P of A union B union C probability of anything is less than or equal to 1. So this means 0.75 less than or equal to P of A union B union C less than or equal to 1. Since probability of any event X less than or equal to 1, probability never greater than 1. So according to addition theorem of probability, 0.75 less than or equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C less than or equal to 1 using addition theorem of probability. So this value 0.75 less than or equal to, so P of A plus P of B plus P of C 0.3, 0.4, 0.7 plus 0.8, 1.5 minus P of A intersection B, P of A intersection C. So minus 0.36. Okay. Next minus P of B intersection C plus P of A intersection B intersection C 0.09 less than or equal to 1. So this is 1.59 minus 0.36. That means 0.75 less than or equal to 1 point. So I hope that you understand 1.59 subtracting from that is 0.36, 1.23 minus P of B intersection C less than or equal to 1. So from this, what can I do? That is 0.75 minus 1.23 less than or equal to minus P of B intersection C less than or equal to 1 minus 1.23. So which I can write, this is 0.48 minus 0.48 less than or equal to minus P of B intersection C less than or equal to minus 0.23. So multiplying by both sides, all the three sides minus, inequality will be reverted. So this is finally 0.23 less than or equal to P of B intersection C less than or equal to 0.48. So before previously after multiplying minus, you will be getting less than or equal to becomes greater than or equal to P of B intersection C greater than or equal to 0.23. So anyhow, this is the answer 0.23, 0.48. So that means closed interval 0.23, 0.48. So accordingly, answer is option B. So similarly, in the upcoming weeks, you are having some other subtopics or topics on engineering mathematics followed by technical subjects. So I hope that everyone understood, good following. Take care, this probability problems, a single letter or single word changes causes big answer, big problem also. Each and every word, every people can understand, but the comparing the question with which definition, that is addition theorem or conditional probability or multiplication theorem, that is tough task. Okay. Hope that everyone following. In the next session also, you are having probability statistics with some other definitions. So I am closing the session. Thank you all. Bye-bye.